Okay, so let's have a look at the 2021 Higher Level Leaving Cert Maths Paper 1, question 7. Now this is a part B question, so it's slightly longer than the other ones, and it is, this particular one anyway, is to do with sequences in series or number patterns. So let's have a look anyway. We have the tip of the pendulum of a grandfather clock swings initially through an arc length of 45 centimeters. On each successive swing, the length of the arc is 90% of the previous length. Complete the following table by filling in the missing lengths here. Okay, so we have started with 45 centimeters, so we're going from 45 centimeters from here to here. So on the second swing then it's just going to be 45 times 0.9 or 90% of 45 and so on. So you just got to fill these in. So very simple start to this question. Now I'm just going to put in the values. I've worked them out. So we have 45 to start with. Second one here is 81 over 2 or 40.5. They have it as a fraction here, so you can leave it as a fraction if you want. It doesn't really matter. That's 36.45 here. And the next one then is 6,561 over 200 or 32.805. And the last one, well, the calculator just gives it as a decimal, so it's 29.5245. 29.5245. So that's it. Very simple start to that question. Okay, part 2 then, we have Tn is equal to 45 times 0.9. It's reducing by 10% each time, so multiply by 0.9 and then we raise it to the power of n minus 1. Let's just work this out anyway. So we have to find the arc length of swing 25 correct to one decimal place. So in other words, we've got to find T25. So T25 is going to be 45 times 0.9 to the power of 25 minus 1, which is 24. And when you work that out to one decimal place, it's 3.6. That's to one decimal place. Okay, so again, a very simple question there. Let's look at part 3. Find the total distance traveled by the tip of the pendulum when it has completed swing 40. Give your answer in centimeters correct to the nearest whole number. So what we're looking at here is the sum of a geometric sequence. So our formula is Sn is equal to a times 1 minus or to the power of n divided by 1 minus or. Now in our particular case we want S40. So that's going to be a, which is 45. First term is 45. 1 minus or, so our or is 0.9. We want to raise that to the power of n, so that's 40. And then we've got to divide that by 1 minus or, which is 0.9. Okay, and that's it really. It's really just calculator work after that. So stick that into your calculator. We've got to give our answer correct to the nearest whole number. So correct to the nearest whole number is 443 centimeters to the nearest whole number. That's it. Again, fairly straightforward question there. Okay, let's have a look at number 4 here, part 4. Swing P is the first swing which has an arc length of less than 2 centimeters. Find the value of P. Okay, so we have our formula for the term number for a geometric sequence. So that's going to be Tn is equal to AR to the power of n minus 1. Now in our case we want swing P, so I'm going to say TP here if you like is going to be equal to AR to the power of P minus 1, and we want that to be less than 2 centimeters. So we want A, which is 45, times or, which is 0.9. We want to raise that to the power of P minus 1, and we want that to be less than 2. So you just got to solve this really. Okay, so let's what we'll do first is we'll divide by 45, so it's 0.9 to the power of P minus 1 is less than 2 over 45. What I'm going to do now is just get the log of both sides. So let's get the log of the left hand side. Log, we'll use natural log, 0.9 power of p minus 1 less than the log of 2 over 45. Bring the p minus 1 down, so that's p minus 1 multiplied by the log of 0.9, and that's going to be less than the log of 2 over 45. Okay, so next thing I'm going to do is divide by the log of 0.9, so that will give me p minus 1. Now remember, the log of 0.9 is negative, so I've got to flip that around. So it's going to be the log of 2 over 45 divided by the log of 0.9, and then p then is just going to be greater than all of this here, the log of 2 over 45 divided by the log of 0.9, and then we just got to add this 1. Okay, so when you work all that out, I'll just come up here. That will give us p is greater than 30.55 and so on. Okay, so our question was swing p. So swing p is going to be a whole number. You can't have half a swing. Well, you can have half a swing, but we're looking at whole number swings here. Swing p is the first swing which has an arc length of less than 2 centimeters. So in other words, p is going to be a natural number, so we want p then to be equal to 31. Now we can check that if you like. We can have a look at, so we can check it here. So we know that Tn is equal to this here, or Tp is equal to that thing there. So let's look at T30. That's going to be equal to 45 times 0.9 to the power of 29. When you work that out, you get 2.1195 and so on. So that's over 2. That's greater than 2. We want less than 2. Well, let's say we pick T31. That's going to be 45 times 0.9 to the power of 30. And when you work that one out, you get 1.9. So this is the first one then going to be, that's going to be under 2 centimeters. So you can see that it is P swing number, it is going to be swing 31. Okay, so that's number 4. Let's have a look at part B then, part B1. The length of the pendulum is 1 meter. So we have something like this, our arc here, and then we'll come up here. So the length of the pendulum is 1 meter. So I'm going to leave it in centimeters. I'm going to say 100 centimeters here. Show that the angle theta, so this is our angle here, of swing 1 of the pendulum is 26 degrees, correct to the nearest degree. So we know that this is 45 centimeters along here. We were told that in the question. So we've got to work out what theta is here. Now we know that the length of a sector here is going to be 2 pi r multiplied by the angle divided by 360 degrees. So our length here we know is 45. We've got 2 times pi times our radius here is actually this value here, 100. So we're going to put in 100 here. Then we've got to multiply that by theta, which we've got to work out, divided by 360 degrees. So you've just got to do a lot of manipulation here to get theta on its own. So divide by these 3 and then multiply by 360. So when you do that, you'll get theta is equal to 25.7831, and it goes on, degrees. So we want theta correct to the nearest degree. So theta is going to be equal to 26 degrees. And this is to the nearest degree. Okay, and that's it for part B1. Okay, so part 2 then we have, let's see, it says hence find the total accumulated angle that the pendulum swings through, i.e. the sum of all the angles it swings through until it stops swinging. Give the answer correct to the nearest degree. Well, really what we're talking about here is the sum to infinity. We want to use sum to infinity, which is equal to a over 1 minus or. Now in our case, A is the first angle. So the first angle is 26 degrees. We just worked that out up here. So we have 1 minus, and the angle is going to reduce by 0.9. It's going to reduce 10% actually each time. So we just got to work that out, and that will give us 260 degrees. There's just one thing you've got to look at here, and that's the fact that they did say here hence. So the fact that they said hence here, I'm assuming what they mean is use this 26 degrees. So that's what I'm going to do. If you use the 25.7831, which is the accurate value, you'll get a different answer. You'll actually get 257.831. I would imagine that they're going to give you full marks for both. It would be very unfair if they didn't. So I'm going to assume that this is what they want us to use here, 26 degrees. Okay, so that's it for part 2. So let's have a look at part 3. Hence or otherwise, so let's use the hence because we've done something already that's going to be useful. Find the total distance traveled by the tip of the pendulum when it has moved through half of the total accumulated angle. Give your answer in centimeters correct to the nearest integer. So half of the total accumulated angle is going to be half of 260, which is 130 degrees. Okay, so we're going to use this formula here now, the sum to n, which is equal to a times 1 minus or to the power of n divided by 1 minus or. So we know that the sum of our angles is going to be 130 in this particular case. So our A in this particular case as well is the first angle, which was 26 degrees. We're using 26. We've got to multiply that by 1 minus or, which is 0.9. Raise that to the power of n. We've got to find what n is. Divide by 1 minus or, which is 0.9. Now, let's just work through this. Okay, so first thing I'm going to do is multiply across by 0.1. This is 1 minus 0.9 here. That's just going to be 0.1. So I'm going to multiply across by 0.1 to get rid of it. So multiply 130 by 0.1, that'll give you 13. That'll give me 26 here, 1 minus 0.9 to the power of n on this side. Okay, next thing I'm going to do is, let's see, just divide by 26, I think, because 13 is half of 26. So if I divide across by 26, I'll get a half on this side, and I'll get 1 minus 0.9 to the power of n on this side. Next thing I'll do is just bring over this 1, so I'm going to subtract 1. That'll give me minus a half on this side, and minus 0.9 to the power of n on this side. So let's just change those signs, multiply across by minus 1. The next thing I'm going to do is get the log of both sides. Again, I'll use natural log, you don't have to, but I'm going to use natural log here as well, 0.9 to the power of n. So again, log of half is equal to n log 0.9, bring the n down, and then just take the log half, divide it by log 0.9. That'll give you your n here. So when you work that out, you can do that on your calculators. That'll give you 6.57, and so on. This is our n. So what we actually have to do with this n here is put that back into this formula again here, because what we want to find is the total distance traveled. The total distance traveled. So let's do that down here. So what we're going to do is use Sn is equal to a times 1 minus or to the power of n divided by 1 minus r. Now our n is this number here, s 6.57881. I'm going to use that. So our a, when we're talking about distance, is 45 centimeters. That's the first distance it traveled. 1 minus 0.9 to the power of 6.57881 divided by 1 minus 0.9. So again, this is all just calculator work, and what you get there, when you put all that into your calculator, you'll get 225 centimeters to the nearest integer. And that's it for this particular question.